welcome. In this installment of the C-Suite Spotlight, I'm thrilled to be joined today by Jay Dawani. Jay is a true modern-day polymath. He's a former professional swimmer who qualified for the Olympics, the author of a highly touted Mathematics for Deep Learning book, former advisor for NASA's Frontier Development Lab, former AI advisor, and serial entrepreneur founding several AI startups, and now is CEO of Lemurian Labs. So welcome, Jay.
Thank you, Justin. Happy to be here. Thanks
Absolutely. Absolutely. And my first question with that somewhat lengthy introduction is, what do you do with all your free time?
Justin, I'm a bit confused. I don't know what this free time you're referring to is. Don't think I'm familiar with the concept. All kidding aside, I'm going to avoid getting philosophical about free time and what that means, but there's a few things that I try and do in my spare time. Because of my history with sports, I tend to stay pretty active, doing things like CrossFit and martial arts. I'm a big foodie, so I'm usually out exploring different cuisines and restaurants or cooking and experimenting with food there. I'm a voracious reader, as you can see from behind me. Also love movies. I think I've probably seen every movie that matters from 1970s up until today. And well, mostly because given the demands on time and the stresses founders and CEOs face on a day-to-day basis, it's important to find an outlet. So I try and find as many as I can to keep myself engaged.
Absolutely. We'll jump right into it now. The question we always begin with, what got you into engineering to begin with?
So we are going pretty deep. So I don't know if there was ever a specific moment. If I think back, the thing that I'm the most gracious for is that I have always had a sense of curiosity and have retained that over the years. So from a young age, for at least as far as I can remember, I have liked to understand things. I've ripped apart everything I could find to its smallest, most granular component and tried to figure out how things fit and why, and then try and build them back up together. And hopefully it works when I build it back. Wasn't always the case when I was younger. So like, for example, when I was 10 or 11, my parents went out for dinner and I was home. I was trying to watch a TV show and there was a noise from the fridge. So I dug around, found a screwdriver, and I took apart the fridge. As you can imagine, my parents were not very happy about that. And eventually distracted me. They got me RC cars and other things, and I took those apart too. There was a show called Home Improvement, if you remember. There's a guy named Tim the Toolman Taylor, and he had this thing about more power. That was pretty much, it's always trying to squeeze more into everything, which was kind of fun. And eventually, to prevent my destructive habits, my mom took me to a friend of hers who was a computer engineer, and she just asked me to keep me busy. And he taught me how to code, how to build computers, taught me what all the different parts were, and helped me kind of build this abstraction layer all the way down from Boolean logic and transistors up until writing code and how everything in between worked and fit together. And that was beautifully complicated and fascinating. And that's how I fell in love with computers originally. And eventually I got, a few years later, got introduced to a book called AI Modern Approach by Stuart Russell and Peter Norvig, which was my introduction to AI. And, I got instantly hooked. I didn't understand most of it, but I knew that I wanted to understand the math well and get better at it. And then I found Minsky and Pappert's books, Perceptrons, Semantic Information Processing, and then Norbert Weiner's Cybernetics. And that's always held a place of fascination in my mind. And somehow I always had this feeling that AI was going to be a part of my life. And if done right, it could be a massive force for good. And any technology could be, but AI is where I decided to focus. And engineering, the reason I took to it is the practicality. It's taking science and applying it to solve a real problem that somebody could experience and benefit from. And then I started looking at it again in 2013 when I learned about AlexNet. And I got extremely excited because I hadn't really seen anything exciting happen in the field at that time. And looking around at that time, it still felt mostly like a science. But the promise was there. You could see the applications that could be applied, the impact it could have. So I sort of rediscovered my love for engineering and went from math to applied AI.
Got it. No, thanks absolutely for sharing that. And so you go from engineer to CEO. Can you walk me through how the choices you've made, that the journey you've taken to get to that path?
Sure. I don't think there was ever a moment where I just wanted to be CEO. If I look back in my career, I've always, again, been focused on trying to solve really practical problems. I love being in the code. I love designing product, and I love walking that entire thing. Like, how is the customer going to be interacting with this? What is the benefit they're going to get? Thinking about latency times, the amount of code, the performance that's necessary, how much compute do I have available to me, how much memory is there? But there's this recurring theme. I think it goes back even before my career started. As an athlete, being pretty young and competing pretty intensely, you get used to stress and you start embracing it, and then eventually learn how to use it to your advantage. And I love team sports. Just weirdly ended up in swimming and being good at it, but I love team sports because I love the camaraderie. I love how the relationships you build when you're in the trenches with someone. And when in high school, when we were playing, things like cricket or basketball or football, things always got elevated, and competition usually sometimes bring out the worst in people. People start fighting within the team itself, and that wasn't really moving us along. And I somehow always ended up being the person being like, "Hey guys, let's talk about this. Let's come together. Let's calm down and find a way through this, and we can solve this as a team, and we can go and win." That always came back. I was the person that got thrust in front. I was like, Jay's gonna handle it.
Yeah.
But even when Lemurian started and previous startups, I wanted to go and find somebody who had been in the role before, who could do the better job, and then I could go do the engineering. And I was a little bit shocked in that most of the people that I ended up talking to were more interested in the title than the responsibility. And eventually I came to the realization that it has to be me, because no one will care about Lemurian and its mission and building the culture the right way as much as I do. So Satya Nadella says that there's two kinds of CEOs, parents and babysitters. A parent is somebody who nurtures the company and its people and grows it. A babysitter is somebody who looks after things to keep them as they are to the minimum possible change. Right? In an early day of a startup, you need a parent, somebody who's actually going to be there, who cares enough, who's going to put all of themselves into it to ensure the maximum degree of success. And you have to embrace the fact that people come into these places for each other, not for a policy. You don't need those kinds of formalisms early on. So you have to create norms that get teams aligned on expectations. You can't just implement tools and strategies to create flexibility and connection, like artificially. It doesn't have to be an either or kind of thing either, but you have to find the right balance. And that only comes from a place of true caring, only when you're truly invested. And I don't think at the early days, anyone but a founder could do that. And I've had this measure of a great leader that I try and hold myself to. It's bring clarity, generate energy, solve constraint problems, and foster culture. And I think as long as you do that well, the company should be in a good shape. And the rest kind of takes care of itself, hopefully.
Well, you're clearly doing that well because you've been able to amass an eclectic and an incredibly brilliant team. How have you gone about doing that, Jay?
I think it goes back to that. As long as you're authentic, you understand the problem you want to solve, and you have clarity in the problem you're trying to go after, and the culture is probably the most important, if I think about it. Talking to most people that did end up joining Lemurian, the reason they joined Lemurian was because of the enormity of the mission and the alignment of the culture to their personal values. And that's what we look for.
Yeah. So tell me a little bit, you talk about mission and, you know, over the last 12 months or so, there's been some shifts in that mission. So, and in my estimation, some really wise directional shifts. Do you care to talk to us a little bit about that?
Yeah. So one thing to clarify, I don't believe our mission has changed, only how we've gone about it. Right? So you're referring to us having gone from focusing on the edge towards the data center. And as you well know, Justin, one of the curses of being a founder is that you're optimistic. You see the world for what it could be, not for what it is. And I had a very strong feeling about the robotics world because I do believe in the potential of robotics, only when it's fully integrated with AI. But that just wasn't happening in the time frame that I was hoping it would. So I took an honest look at the workloads, the problem space, where the workload is going, how they would get adopted, and where would they have the largest impact. And I came to a bunch of interesting realizations that led me to rethink the market. And I started talking to other AI engineers at the time as well to get their read on what I was saying. And a lot of people started coming back to me and asking for help with model building and training and deployment challenges they were facing. And I took a look at the models they were building and the amount of compute being used for training, and then trying to scale that model for inference and the rate of progress at which things were happening in the model side. And I did a back of the envelope calculation on the amount of compute required for, say, an arbitrary transformer model and the amount of compute data that would be required in terms of tokens to train said model, and how frequently people would retrain it, the scale at which they would get deployed. And it felt like we were on this increasingly unsustainable path. And compute was not progressing at the rate at which it needed to address that. And we were already building a general purpose accelerator for the edge to do all things robotics and AI. So it was really just refactoring that, moving up the edge, increasing our power envelope, going up to a more modern node. But the shift felt pretty natural. I think it's the right one.
Yeah, no, I absolutely agree. And now, with that being said, you talk about the pace, and as of about a year ago, there were roughly 100-ish AI processor startups or AI process hardware companies. And as of today's recording, there's over 195. So that it's a hot market and a crowded one. So what makes Lemurian different?
That's a lot of companies. 195. So early on, before I decided to do AI hardware, I spoke with a lot of those companies that were around at that time. And I was looking at them because I wanted to train models for self-driving and then for inference in those environments. But the thing that became clear to me is they didn't have a grasp of what the actual problem was. Most of them were too focused on chasing some magical tops per watt number that they thought would allow them to crush NVIDIA or create good marketing statements. Whereas, me being an engineer, what I cared the most about was how well is my code going to run on their stack, given I'm already writing it here and I'm productive in this environment. And what is the realizable performance I can get on that hardware, not the theoretical. I want to get real things done, right? And the path that most of them it took to get performance was reduced precision. So instead of FE32 and BrainFloat and FE16, they all went to 8-bit integers, and some went below that. And then they started exploiting sparsity and so on. I think that was a premature move. Because different neural networks are looking for different things. They respond differently to quantization. Everyone's been trying to keep everything on chip for inference, but model sizes are growing, so you can never actually store things on a chip. And there's different trade-offs to make in actual production environments as well. But I think the mistake really comes down to people thinking that the workload wasn't going to change. Right? The one thing we know is neural networks are going to continue to evolve. There are these priors that we use for neural networks. For example, convolutional networks always going to be great for images. Transformer networks is going to be used for when you want to be permutation invariant, that we can look at all that data. And it's an incredibly powerful architecture, but I don't think that is where we stop. I think there's going to be more coming after that. And if I'm an inference accelerator, the maximum performance I can get is by specializing for certain operators. But what happens when the workload changes again? Your value proposition is no longer there.
Right.
The only way to continue to progress the field of AI is to have an accelerator that is balanced for training and inference and has to be general purpose. And there's one other thing that I'd noticed in the industry, which I don't know where it comes from or why that mentality exists, but software has always been an afterthought, it seems. Right? A lot of companies, they have great computer architects coming in. They look at the problem. They're like, there's very simple operators. We know how to make that go fast. And they agree on a design. And then once they're done, they throw it over a wall to the software engineers, with some pizza and coffee. And they're like, make this usable so that external customers can now do stuff on it. And, I have my own bias. I'm coming from a software background. And to me, it felt like we should be doing it the other way around. Let's start with software. Look at how engineers are writing code. What code are they writing? Where are they writing it? What are the problems they're actually facing? Where's the workload going to shift? Work our way down from there. Think about if the workload is going to shift, what are the things that stay static? In a fast-moving world, you shouldn't really be focusing on the change. You should be thinking about what are the things that are not going to change, because that's your opportunity to create value. And then the rest becomes, in our case, how much programmability you need. Right? And with that understanding, we can think about what the hardware has to look like. But we also had a couple of understandings, findings, which was, if every single company in the world has the same IP and the same constraints and the same software stack they have to run, or workloads they have to run, the difference between the different hardware is going to be marginal. So you might as well just stay with the one that has been there all along that you're already productive with. Right? And this is where our thinking around number systems came. Number systems open up the design space and allow you to do more from the same silicon as you could before. So deep learning is all about multiply accumulates, right? It's just lots and lots of multiply accumulates, but in an ordered fashion. So that is something we can exploit. And what we were seeing is there's a trend where we're going to start running out of bits. And that's purely in the pursuit of trying to get performance out. What we want is to maintain that goodness in terms of precision and dynamic range while still getting an overall performance efficiency boost. So we create a new number system that is optimal for neural networks in terms of precision and dynamic range they require, and is smaller than floating point and integers. And that's allowed us to essentially, as we call it, take engineers to the limit of physics.
That's awesome. That's awesome. And I think anybody could get excited about that. You mentioned earlier on in our conversation the constructive nature of AI, and you've heard, I'm sure, the loud detractors, the concern about the destructive nature. What, if any, concerns do you have about AI being misused or becoming destructive? And what are the guardrails we can put around that?
I think with any technology, you will have that conversation. Right? Any technology could be, technology itself is not good or bad, it is the people using it. Right? Now, there are some issues with the current way AI is built. Most of the issues, it's not the model itself, although in some cases it is. It usually comes down to data. So data privacy is an issue. The kinds of things that you can use it are an issue. For example, if you have a model that is just, you scrape all the data off the internet, the things that are abundant on the internet is negativity. A lot of conspiracy theories, a lot of false information, people telling certain narratives. And now, if you have a very large overparameterized model, it isn't distilling that or condensing it, it is memorizing all of it and storing that as raw facts. Now, all you need is somebody who can come up with a kind of prompt and access certain information. Now, the model is giving certain outputs that it shouldn't, right? And there are issues like that. I am hopeful. I think, so I mentioned earlier that I don't believe we're done exploring models yet. I think the path forward is likely going to be that we may be seeing the limit of transformer models because we're starting to run out of data. And I personally have a feeling that there's going to be an emergence of a new architecture soon, in the next, anywhere between from the next 6 months to the next 2 years, or maybe longer. And this architecture is going to have a few criteria. It's going to allow for continued scaling of model size, because we do know that greater model size results in new emergent properties. If you look at the brain, for example, there's a roughly 4 order of magnitude difference to the parameterization of that, versus the amount of data samples you pick up over your lifetime. I think larger model is going to create more stability and steerability, so you can have better control over outputs and eliminate hallucinations and take more complex goals at higher levels. And it's going to create essentially a goal-oriented architecture instead of a prompt-based one. We may have a world model which works as a source of ground truth. And from that, you can think about having a generative capability. You're making predictions about potential futures, and then you're applying some form of a cost function to that to improve reasoning abilities. I think multimodality is going to play a more important role. And that way you can have more context about the environment. Think like a joint embedding space where words and images have strong and weak ties, and relationships can be traversed and played with, and so on. And I don't believe it's going to execute a predetermined number of steps to get to an output. I think you could defer more compute to runtime, where you can scale up the model and have larger state space. This is something AlphaGo Zero did as well. So it's a pretty powerful concept, because traversing through a predetermined number of steps or layers to get to an output is somewhat limiting. You don't know the amount of computation you actually need to solve the problem, or how much reasoning you need. So I think that's going to be somewhat goal determined.
Yeah. And
how the granularity to which it breaks down. I think models are going to have to get more sample efficient. That way, the DNN generalizes with fewer data points while still being very overparameterized. And this could come possibly from the discovery of a better prior. I think architecture should be somewhat modular, so that parts of the model could be retrained without having to redo the entire model from scratch, which could become expensive. And that way you can overcome data concept drift types of things as the model interacts with the world, and maybe align them better to users and their individual needs and personalities. And then, adapt to new contexts as users are giving them. And least by my estimates, if I actually try to construct that, I think it's going to require somewhere between 3 to 4 orders of magnitude more compute than what we've seen today. And today we're already at zettascale,
Yeah.
Which is kind of ridiculous. But I think that's how we solve the problem.
Awesome. So bringing it back to Lemurian and what you guys are doing, what is the most exciting near-term horizon? Like, what's the most exciting either market reaction or the most exciting near-term development that you could share with us?
I think the most exciting thing is when people start recognizing the work you're doing and they see value in it.
Mm-hmm.
I agree with the thesis that you had. So a big part of it for us was we don't believe that the world is going to be a great place if only a few people have the ability to build very, very large models and everyone else in the world relies on them. That creates a certain consolidation of power to those companies that is unfavorable to everybody else.
Mm-hmm.
So for us, we believe in the democratization of AI, and that only comes from when you've commoditized exascale computing. Then every company can basically go buy their own exascale computer, be a part of the game, and build more models, and that's going to bring more information to light about the limitations of things and get more awareness to everybody. So we've been talking to a lot of companies that like the way we're thinking about it, our general approach, the ease in which we are going about it. So you can adopt this very quickly and get productive really quickly. Our architecture is designed for utilization. So you have a chip that is capable of multi-petascale performance that is somewhat power efficient too, and you get much more utilization and throughput out of this thing.
Mm-hmm.
And you stay in a high-level language and you get all of that benefit. And it's also designed to scale out. So as you're scaling it out, you're getting more and more of a benefit. And that reduces your cost. So if you like iso-normalize with power for performance and throughput or something else, you always end up a little bit ahead.
Yeah.
With the way we've been thought about this. And people seem to like the thinking that we've had, the generality, the programmability. And also a lot of people have been complaining about the fact that they are running out of bits and that's causing problems.
Mm-hmm.
Models are not behaving well or as well as they had hoped after they have quantized. And the amount of dynamic range and precision that we're giving is exactly what is required. And I had one company actually refer to the format we created as a hero format, which made me feel really good about the work we're doing. But yeah, overall responses have been positive. I think we have a long journey still, and I think AI is still in its early days. So it's going to be an exciting couple of years.
Absolutely. You talk about the early days, and you've got a long road ahead. Well, I mean, part of solving these problems means having the right people tackling them. What are some of the, or what are the two biggest talent attraction issues that you've had at Lemurian?
I think the first and foremost is we're a young company with a modest amount of funding. And a lot of people that would be looking to join us are used to a certain kind of salary range. That makes it hard for us to hire, at least right now. I think that problem is going to get fixed over time as we continue to hit more milestones and make progress and get customer demand and traction. But yeah, I think a lot of people have been burnt by startups in the hardware space, and they're cautious, and rightfully so. Startups are hard. Right? It takes a particular kind of person to want to go through that kind of suffering.
Yeah.
But I am pretty hopeful still. We have hired as many people as we need right now for the tasks and the goals that we need to hit for this year and the next. And We're probably going to be growing the team again in the next 6 months or so. And I think people are going to be more educated about the space, and they'll be able to make better decisions.
How have you gone about solving for that problem? Like I said, you've amassed a very good team. So how have you solved for that?
Well, great recruiters help. It's challenging in our case. Like, we were in stealth for a while, so most people didn't know that Lemurian existed. We're coming out of stealth this year, so I think that's going to help with bringing more awareness to the work we're doing. But mostly we've gone through people that we know and trust, and they've helped. Like, they believe in the work that we're doing. Our investors, for example, they really believe in the work that we're doing, and when they find a great candidate, they send them our way. And sometimes it's a fit, sometimes it's not. We tend to look for a particular kind of person, and so we have pretty big filters, large filters for kinds of people we know are going to be successful at Lemurian.
Absolutely. Well, you are going to be speaking at the prestigious AI Hardware and Edge AI Summit in California next month that I'll be attending. Can you give us in attendance a little bit of a sneak peek about what you're speaking on?
Yeah. This may change, so don't hold me to it.
Okay.
I'll be speaking more specifically to how I see the workloads changing and what that means for programmability and hardware specifically. I'll also be speaking around how we've thought about number systems and that problem and gone about solving it. And then ultimately, how we plan on bringing down the cost of compute for AI so that every single person can benefit from it. So it's going to touch on those three things.
Awesome. Well, I can't think of anybody better to be talking about those items. And in that time frame, in 6 months or when that time comes, when you are looking to add to the team, what would you tell an engineer? Why should they want to be a part of Lemurian?
They should only be a part of Lemurian and want to join us if they're hell-bent on solving a really hard problem and making a difference. We do not half-ass it. We are all out every single day. Because I think the end result demands it. It's easy to take things for granted, right? In a world where you have behemoths in the space and they're doing an excellent job, right? We have to do it better and smarter and more efficient, and that requires commitment from people. So we ask a lot of people, and we're not really looking for folks that are been there, done that, we know everything. There is no expert on the problem that we are trying to solve, right? We are learning as we go, and we are constantly reacting to changes in the market. We don't get to influence it. No semi company really does, right? Our job is to give freedom to engineers, the software engineers and model builders, so that they can continue to innovate and do things. So yeah, we're looking for folks that are patient and are in it for the long game and believe in the mission. And it's only if you have those three things and you have the ability to pick up skills quickly, then I think you're going to find a home in Lemurian. It was interesting. One of the early engineers that joined Lemurian actually said, Lemurian's a place for all the wayward engineers who couldn't find a home anywhere else, and they get to come here for troubles. That's kind of nice, especially because I'm a Star Wars fan.
Well, absolutely. And I, for one, thank you for taking on the Herculean task that you guys have, because democratization is one of the things that I personally feel is key to healthy growth within the AI space. So thank you. Jay, would you like to share with anybody how to find you, or how to keep in touch with you or with Lemurian?
Yeah, LinkedIn is probably the best place. If you want to reach out, you can through the website. We have an email, and you can just shoot us a note, and we'll respond.
Awesome. Well, I personally thank you for the time. I look forward to the developments, and also look forward to seeing you out in California in about a month.
Absolutely. See you there.
All right. Thank you.
Thank you, Justin.